Hey everybody, Mr. Gibson here. So I wanted to record a video to help get you started on the balancing chemical equations Gizmo. So yesterday you did a hook about balancing chemical equations and it introduced this idea of the law of conservation of mass. And what that means is whenever we describe a chemical reaction with a chemical equation, we have to make sure that no atoms are being created or destroyed. So we must have the same number of each atom on the left side of the arrow or the reactants as we do on the right side or the products. Okay, and that's not just the same total number of atoms, it's the same number of each individual atom. So you can't have like two hydrogens on the left and one on the right. It looks like an atom has been destroyed, and that can't happen. All right, so it says watch the video. That's the video we're watching right now. This can be a little bit time consuming, the balancing chemical equations deal, especially if you're writing it out on paper and walking through the whole process, as I probably recommend that you do, but that can add some time. So because of that, I'm giving you 2 days to complete this assignment. So this is going to allow you to explore how chemical equations, or how to balance chemical equations, and it's going to introduce a little bit of the different kinds of chemical equations and chemical reactions that you'll see. Technically, we won't cover those in depth until 5.3, but you're going to get a little sneak peek at them today, okay? So to begin, you're going to open up the Gizmo on the Gizmo website, okay? And then you are going to open up the Google Doc. All right, so here you've got some prior knowledge questions. If a candle is placed on one pan of a balance and an equal weight is placed on the other pan, what would happen when you lit up the candle and waited a while? Well, some of the wax is going to melt, some of the wick is going to go away, some of it's going to evaporate, some of it's going to undergo that combustion reaction, and so you're going to lose reactants, you're going to lose products to the atmosphere that are being converted to a gas, and so some of that balance may shift, right? So suppose the candle was placed in a large sealed jar and allow it to burn for several minutes before running out of oxygen. The candle and the jar are balanced by an equal weight. In this solution, what would happen if you lit up the candle and waited? So what do you think would happen if we trapped all those gases in that container while we're burning the candle on the balance? Well, the overall weight of the system now wouldn't change because you're keeping those gases from being released into the atmosphere. And this is actually very similar to a chemical reaction done by Antoine Lavoisier, who was the father of modern chemistry, and he discovered that when you burn something like a candle, you're not destroying the matter within that candle. You're simply causing a chemical reaction to happen, and sometimes the products are gaseous, and so they'll leave the system and go into the room if you don't have a closed system, like it's describing in number 2. But if you have a closed system, it's going to weigh exactly the same before and after the chemical reaction. Okay, so it says burning is an example of a chemical reaction. The law of conservation of matter states that no atoms are created or destroyed in a chemical reaction. Therefore, a balanced chemical equation will show the same number of each type of atom on each side of the equation. Okay, so to set up an equation for the chemical equations Gizmo, type the chemical formulas into the text boxes of the Gizmo. First, type H2 plus O2 in the reactant box. So let's go ahead and do that. All right, so we're going to launch this Gizmo. And it logged me out, so let me log back in. All right, so it said to type H2 plus O2 in the reactants box and H2O in the products box. So in the reactants box, we're going to type H2 plus O2. There's our reactants, and then in our products, we're just going to type H2O, which is water. Boom, there we go. All right, so we've got our skeleton equation right here, right? And what this has done is it's gone through and it's counted out the number of atoms in the reactants for each element and in the products. All right, so it says how many hydrogen atoms are on the reactant side, okay? On the product side. How many oxygen atoms are on the reactant side? How many are on the product side? Let's go back and count. So we've got 2 hydrogen atoms, H2 on the reactants, 2 in the products. So that seems to be balanced as far as hydrogen goes. But look at the oxygen. We've got 2 atoms of oxygen in the reactants and only 1 in the products. Okay. So if we go back here to our question, based on what you see, is this equation balanced? No, it is not balanced, because it looks like oxygen has been destroyed. It looks like this atom has just gone into nowhere, which can't happen. So right now, this does not obey the law of conservation of matter. If it did, we would have equal number of hydrogen and oxygen on this side as we did on this side, and we don't see equal numbers for the oxygen. All right. So what this is going to continue to do is it's going to help you learn what a subscript is, what a coefficient is, and it's going to teach you how to balance a chemical equation so that it obeys the law of conservation of mass. All right, guys, if you have any questions beyond what I've already introduced to you, or if you get stuck on anything and need some help, feel free to email me. All right, guys, good luck.